All right, we're going to use tape diagrams and tables to make sense of percent problems. We're going to give percent problems a visual representation that's going to help our students understand percents so that they can actually invent their own techniques in order to solve this problem on their journey towards the standard algorithm that you want them to know. So let's get started. All right, so we're going to start with finding the percent. And it says there are 15 students on the basketball team. And there we go. And 9 students on the team are right-handed. What percent of the team is right-handed? All right, so now what we're going to do is we're going to use a tape diagram to represent this story. Now, a tape diagram, when we're dealing with percents, we're always somewhere in that percent problem is this ratio that involves the number 100%, that value of 100%. And in this case, actually in every case, I tend to start by drawing a tape diagram and saying, okay, that tape diagram, that entirety of that tape diagram represents 100%. And then what I'm going to do is I'm going to read through the problem again, and I'm going to see if I can add to this pictorial representation. So it says there are 15 students on the basketball team. 9 students on the team are right-handed. What percent of the team is right-handed? So that idea of that 15%, that 15 students, that represents the entire basketball team. So I'm going to represent that right here. So that represents the entire basketball team. So those 15 players represents the entire basketball team. Now it says 9 students on the team are right-handed. So, well, heck, if that whole thing represents 15 students, half would be 7.5, so 9 would be, I don't know, it doesn't exactly matter where. So let's estimate that 9 is right here. So this portion right here represents our 9 students. So I'm going to write that down right there, 9 students. So I don't like how my drawing is ending up, so I'm going to kind of change the picture just a little bit. I'm going to change this to be, there. So 15 students is the entire thing. And then I'm going to say, okay, and then this little chunk right here represents our 9 students who are right-handed. And then it says what percent of the team is right-handed. So we start to see that 15 and 100 kind of are both represent the entire tape. And then we see that 9 represents a portion of the tape, but we don't know exactly what percent that is. So I'm going to include that right here, and I'm going to call that P for percent. So there is my pictorial representation to represent this story. We begin by drawing that entire tape diagram representing 100%. And then we go back and we read the problem multiple times, filling in the rest of the picture. There are 15 students on the basketball team. That represents the entire team. So that kind of goes together with that 100%. And then 9 students is only a portion of that tape. And we don't know what percent that represents. So I'm going to use the letter P for percent. Okay. So now that I've got this pictorial representation of what this percent problem looks like, I'm going to shrink it down just a twinge, and I'm going to connect that that tape diagram with a table. All right, so what is that table going to look like? Well, we're going to take this and extend from our proportions chapter that we probably just finished. And so we remember we used an XKY table in that chapter. So in that chapter, we used an XKY y, where of course we know that in a proportion, the formula is x times k equals y. That k represents our constant of proportionality. Now, in this story, when we're dealing with percents, we're often going to think about that x representing the whole, and then we're going to think of the y representing the part. Technically speaking, if students flip this around, they'll still get the answer right. Their k will just be the reciprocal, but don't tell students that. Okay, so anyway, we've got the whole and the part. And now let's take a look at our picture and what values represent the whole. Well, I see that the number 100, the 100% represents a whole, and I also see that 15 represents the whole. So we're going to put both of those values in the whole column. It doesn't matter which one goes first. I guess I'll just put the 15 first. I'll say 15 goes first, and then we say, well, 15 has an associated part. So in our picture, 15, if 15 is the whole, what is its associated part? It's the 9, right here. And then I'm going to create as many rows of equivalent ratios as I want. It doesn't matter how many I have. And then looking at my picture, we have another whole, don't we? 100% is another whole value. So I'm going to write that down. So 100% is another whole value. And what is its associated part? In this case, we don't know. It's P at this point. So we're just going to write the letter P to represent the fact that we don't know what the associated part is. So now we've got any one of a bazillion different ways that students can go through this table and simplify and solve this table so that we get the answer. Using just plain old vertical manipulation, what might students do? Well, and I'll do this all in red. So students might, in order to find that missing value P, what students might do is they might divide both of these by 3. Because remember, whatever you do to the X column, you've got to do to the Y column in order to maintain that proportionality. And in which case we get, I'll stick with the red, we get 5 and 3. Oh, which makes it easy for us to then see that, 5 times 20 gives me 100. So 3 times 20 gives me 60. So we now know that P represents 60%. So that's just using vertical table manipulation. Let's think about the horizontal, because we are in 7th grade. We want students to become familiar and comfortable with that constant of proportionality. So let's look at our constant of proportionality. We know that 15 times something has to equal 9. So 15 times something has to equal 9. So using division, 9 divided by 15 gives us that missing value, and so that is 9/15. So now that we know our constant of proportionality is 9/15. But some students might say, wait a second. It looks like here our constant of proportionality is 3/5. It looks like we have different constants of proportionality, which means they're not constant and it's not a proportion. But we want to remind our students that 9/15 and 3/5 are indeed equal to each other, or equivalent, because all we have to do is divide by a scale factor of 3 and we get 3/5. So 9/15, so 9 divided by 3 is 3, 15 divided by 3 is 5. So therefore, we know that 9/15 and 3/5 are equivalent fractions, equivalent ratios, which means we do have a constant of proportionality, and our constant of proportionality is 9/15 or 3/5, depending on what you want to say, because they're equivalent. Well, now that we know what our constant is, that means we can just, and I'm going to zoom in a little bit here, we can multiply 100 by our constant of proportionality to get the value of p. So what is that? So that's going to be 100 times 3/5 gives us p. And we know how to multiply by fractions. That's 100 over 1 times 3/5 equals, and then I can just do the math. So I could go straight across, multiply straight across, and I get 300 over 5, and 300 divided by 5 gives me 60. And so we know that in a different way that the value of p is 60, meaning 60%. So we had a couple of different ways to move through that table. We could do it through vertical manipulation of equivalent ratios, or we can find the constant of proportionality, which allows us to go horizontally. 7th grade teachers, ultimately, we want to get going. We want to go with this horizontal relationship utilizing the constant of proportionality. If you're a 6th grade teacher, you can stick with just this vertical manipulation because equivalent ratios is totally fine in 6th grade. But in 7th grade, we want to begin moving horizontally using that constant of proportionality. So what did we do? We began with a graphic organizer. We began with a tape diagram, and that tape diagram in its entirety represented 100%. Then we just continued to read through the story multiple times, filling in the rest of our picture. Then we used that picture to create a table, and then we filled in that table using either vertical manipulation or horizontal manipulation. And that's one way to go about solving this problem. There's other ways, but I'm going to, in this series of videos, I'm going to be using the idea of using a tape diagram to visually represent the story, and then use a table in order to keep track of our calculations.